Welcome back to another lesson. Here's our 3.3 notes. We're going to learn about how to prove that lines are parallel based on the angle relationships that we see. There's a lot of vocab here. Most of the vocab we've already gone through, so I'm not going to write a lot of these, but I do want to point out the first one here, converse. Remember, our converse is if we have something like Q implies P. So that's where we flip our conditional statement, what's in the if and the then, and we re-say it. And today we're going to do the converse of the theorems that we learned in lesson 3.2. So everything here is going to deal with the transversal, and then we have the angle relationships of corresponding, alternate interior, alternate exterior, and consecutive interior. So everything's the same, but today we're going to do the converse. So let's look at theorem 3.5. It says corresponding angles converse is where if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So we get to prove parallel lines using our converse. So in this situation, if we see that we have angles that correspond with each other that are both congruent to each other, then we can say the two lines are parallel. Let's go to the next page. So then we have the converse of our alternate interior angles theorem, same thing. Now it says if we see that the alternate interior angles are congruent, then the two lines cut by that transversal are parallel. We also have the alternate exterior angles converse, which says if we see the alternate exterior angles are congruent, then the two lines cut by that transversal are parallel. The other angle relationship we talked about was consecutive interior angles. And here, if we see that the consecutive interior angles are supplementary, so they add to 180 degrees, then we can say that lines J and K here are parallel. And then the last property here is transitive property works in a lot of different ways. And there's a transitive property of parallel lines. And this states, hey, if I have two lines that are parallel, let's say P and Q, and then I also know Q and R are parallel, then the transitive property says now I can jump to saying P is parallel to R. So that's the transitive property of parallel lines. So I know I went through all those theorems quite quickly, but let's just use those in some problems. So in exercise 1 and 2 here, we want to find the value of x that makes m and n parallel and then explain our reasoning. So what I want to do is I want to show that these angles are corresponding, but if we can make them congruent, we can say that our reason here is going to be that we have the corresponding angles converse. That's going to be my reasoning. But for that to actually work, I need to make sure they're congruent. To make sure they're congruent, I'm going to set these equal to each other. So I'm going to set 95 equal to 8x plus 55. And I'm going to solve. So I'm going to subtract 55 from both sides and get 40 equals 8x. And when I solve, I get x equals 5. On number 2, I see the relationship of alternate exterior angles. So if I want to prove lines M and N are parallel, my reason is going to be I need to show that my alternate exterior angles are congruent. And then I can use their converse to say, hey, lines M and N are parallel. So for that to work, I need to set up 200 minus 2x equals 130. I'm going to subtract 200 from both sides, get negative 2x equals negative 70. And that gives me x equals 35 when I divide both sides by negative 2. Let's look at this next one. This next section here, I'll zoom out a little bit, says to decide whether or not there's enough information to prove that the two lines are parallel. If so, what theorem would we use? So I see an angle relationship. I see corresponding angles with number 3. I see corresponding angles. They are congruent. So I would say yes. And the reason why is I have my corresponding angles converse. I could use that theorem to prove that M and N are parallel. Now, on number 4, the only relationship I see here is I see vertical angles, but vertical angles helps if I can spell vertical. Vertical angles do not do anything about parallel lines. So I'm going to say that there's not enough information. So there, I don't know if these are parallel or not. Now, when I look at 5, I see vertical angles again, but vertical angles don't help me right now. It just tells me about this one intersection. So I'm going to say not enough information for number 5. Now, when I look at number 6, I'm going to redraw this. I have line M and I have line N, and I have my transversal here called R, and then I have these two angles here that are congruent. So I see alternate exterior angles that are congruent, but they're only with lines M and N. So I can say my alternate exterior angles converse theorem. Remember, you have to write the word converse because that's the theorem. The theorem says if we see this angle relationship that has like the congruency going on or the supplementary relationship going on, then it proves parallel. So there's enough information, but that's going to prove that lines M is parallel to N, not S with anything else. So yes, they are parallel. All right. So that is the end of our notes today. If you have any questions, feel free to reach out. Or if you don't have any questions, we'll just see you in class or in the next video. Have a great day.